In this video, we'll explore operations with fractions in Math 8. It's important that your child makes sense of operations with fractions. Let's begin by getting to know some thinking tools that can help us make sense of operations with fractions, pattern blocks. If you don't have access to pattern blocks, you can draw them. Or use a virtual app. The Math Learning Center offers several free virtual math apps. These are available for web browsers or devices. Type the URL on the screen in your web browser and open or download the Pattern Shapes app. Let's get to know the pattern blocks. Suppose that the yellow hexagon has a value of 1 whole. What are the values of the other shapes? How do you know? The red trapezoid has a value of 1/2. 2 red trapezoids cover the yellow hexagon. The green triangle has a value of 1/6. It takes 6 green triangles to cover the yellow hexagon. And the blue rhombus has a value of 1/3. 3/3 cover the yellow hole. These blocks can be combined. How many different ways can you cover 5/6 of the whole? Can you find all of the ways? Press pause. There are several ways to make 5/6 with these fractions. You might have combined 1/2 with 1/3. We can visualize that this represents 5/6. Imagining 2 lines convinces us that this is true. This also helps us develop a procedure for adding fractions. 1/2 is equivalent to 3/6. 1/2 and 3/6 are called equivalent fractions. 1/3 is equivalent to 2/6. These fractions have a common denominator. Each is expressed with the same number of pieces, 6, making the same whole. This illustrates another way to make 5/6 that you may have discovered earlier. Combining 5/1/6 makes 5/6. Here's another way. We can see that 1/3 plus 1/3 plus 1/6 is 5/6. Can you show that this is true using what we've learned about adding fractions? Use equivalent fractions with common denominators. 1/3 is equivalent to 2/6. 2/6 and 2/6 and 1/6 make 5/6. We can add the numerators over a common denominator. What about subtraction? The pattern blocks can help us understand subtracting fractions as well. What do you think 1/2 minus 1/3 looks like? Can you draw a picture? We can think about subtraction as removing or taking away. Imagine taking 1/3, a blue rhombus, away from 1/2, a red trapezoid. This leaves behind a triangle, which is equal to 1/6. Again, we can see common denominators at play. 1/2 is equivalent to 3/6, and 1/3 is equivalent to 2/6. Subtracting the numerators over a common denominator leaves the difference. Subtracting can also be thought of as comparing. The difference between the red hexagon and the blue rhombus is the green triangle. 1/2 is greater than 1/3 by 1/6. The number line is another representation that helps us make sense of fractions. We jump 1/2 to the right, then move 1/3 to the left to subtract. We land at 1/6. Dividing the line into 6 illuminates the method of using a common denominator. Next, let's explore multiplying fractions. We can think of 2/3 times 3/4 as 2/3 of 3/4. Draw a rectangle and cut its length into quarters. Then shade 3/4. Draw lines to cut its width into thirds. Find 2 of these thirds, or rows. This gives 6 of 12 squares shaded. The product of 2/3 and 3/4 is 6/12. Let's take a closer look at the numerators and denominators of the factors and the product. What do you notice? How are they related? Notice that 6 corresponds to the product of the numerators, and 12 corresponds to the product of the denominators. What about division? What does it mean to divide fractions? Next, we'll turn to an example from the kitchen. How many 1/4 cup measures are there in 1 1/2 cups? How do you know? The question is asking us to determine this quotient. We can visualize the filling of the 1 1/2 cups 1/4 cup at a time. Let's pause here. This makes sense. There are 4 1/4 cup measures in 1 cup. And 2 more in a 1/2 cup. There are 6 1/4 cup measures in 1 1/2 cups. Again, let's use this diagram to help us develop a method for dividing fractions. The mixed number 1 1/2 can be expressed as an improper fraction, 3/2. 3/2 can be expressed as an equivalent fraction, 6/4. This expression is asking the question, how many 1/4 are there in 6/4? 6 divided by 1 is 6. We can divide fractions by writing them with a common denominator and dividing the numerators. Let's compare 2 similar multiplication and division calculations. We'll compare dividing by 1/4 with multiplying by 4. 4 is the reciprocal of 1/4 because 4 times 1/4 is 1. The division is shown on the left, the multiplication on the right. Notice that the result is the same. We can divide by a fraction by multiplying by its reciprocal. Let's try one. 9/10 divided by 3/5 is equal to 9/10 times 5/3. 5/3 is the reciprocal of 3/5. Multiplying the numerators and denominators gives 45 over 30. This is equivalent to 3/2, or 1 1/2. The diagram on the left shows that there are 1 1/2 3/5 in 9/10. Let's apply our understanding of operations with fractions to some problems from the textbook. To add these two fractions, what we think of as 1 must be the same. But now the sizes of the pieces are different. We can express both 6 and quarters as 12ths. Combining 2/12 and 9/12 makes 11/12. Julia needs 3 1/2 sheets of plywood to finish a wall in a workshop. She has 1 1/3 sheets of plywood. How many more does she need? We can think addition to solve this problem. Halves and thirds can be expressed using sixths. Adding 1 to 1 2/6 makes 2 2/6. Adding 1 more makes 3 2/6. 1 more 6 makes 3 3/6. The solution to this problem can also be expressed using subtraction. We can find the difference between the two amounts of plywood, working with improper fractions if easier. One summer day in Masset had 10 1/2 hours of daylight. It was sunny for 1/3 of that time. For how many hours was it sunny that day? This problem can be solved by finding 1/3 of 10 and 1/2. Continuing to calculate the product as before gives an answer of 3 and 1/2 days. Next, we'll look at a common mistake that students might make. Students might add both the numerators and denominators. After all, multiplying both numerators and denominators works for multiplication. But this does not account for the size of the whole. There are two different sized wholes, and then a third. This calculation is incorrect. Estimation can convince us of this. 3/4 is already greater than 1/2, whereas 4/10 is less than 1/2. Let's look at how this video addresses several learning standards in BC's Math 8 curriculum. In content, we learned about operations with fractions. Several curricular competencies may emerge as your child learns this content in their classroom. In this video, we use tools or technology, like pattern blocks or virtual pattern blocks, to create a method for adding and subtracting fractions. We developed an understanding of dividing fractions through solving a problem involving measuring cups. We represented fraction concepts pictorially.